Hello,
Sir.
am I audible?
Yes, sir, audible.
Yes,
Okay,
sir.
okay, okay. Is it visible? Screen is. Can you able to visible the screen?
Yes, sir,
Yes, sir.
visible.
Okay. Shall we start?
Okay, sir.
Okay.
Good afternoon, sir.
Good afternoon. Good afternoon to one and all. So welcome back to virtual laboratory. Dear students, in the last class we have been discussed about the first experiment, uh, which is in our list. uh, Once we are looking into the syllabus, so we have a part A and part B. So majority of the experiments which are comes under the through this laboratory, which are comes under the uh, major experiments. Now yesterday we have been discussed one minor experiment, that is Rockwell harness testing machines. We have been discussed. So I hope you understand how we are going to conduct the experiment. This is where we are trying to explaining you to virtually. So whenever we come across to the laboratory, definitely we will all together we will conduct the experiment in practically. So because we have to have that practice anyhow, so we are at least so we know how to conduct these experiments by virtually. Yesterday we have been discussed about the Rockwell harness testing machine. I hope you know very well. I think you have get an idea about how to conduct the Rockwell harness testing machine. It's a very simple experiment. Aim of this experiment, we need to determine the harness value of the given sample. Right. The very simple steps are in procedures. We have to follow that procedures. We make ensure that machine will be properly work. Then we can get the or we make ensure all the parameters should be in proper, then we can get the Rockwell number, correct Rockwell number. Then you can record it and then you can write it in the results. uh, Hardness value of the given sample is this much, like this you have to write in the results, right? The today shall we discuss the one more hardness test, that is Brinell hardness test. Yes, as I told you in the beginning class, in the hardness is one kind of the mechanical property, and also we have been defined this hardness, the ability of the material to resist the indentation, penetration, scratches, some cuttings or flaws over the surface due to the applied load. If that material will not allow to get easily the registration get not easily get the indentation, penetration or scratches over the surface, hence we can call them as a hard materials. I hope you understand this. To determine this hardness property of the engineering materials, here we have a three different methods. At one, Rockwell testing machine. Second one is right now we have a Brinell harness machine or Brinell harness testing machine, and one more is there, that is a Vickers harness testing machine. I told you that yesterday all the three machines are having their own perspective or own principles. Based on that, we need to uh, understand how to conduct each process or each techniques or each experiments, what will be the working principle and what will be the difference between all the three experiments, that we need to understand. But all the three experiments, aim of the all the three experiments is the same or single, to determine the hardness value of the given sample. But some of the materials are suitable for the any one of the experiment. Depending upon the materials, here we are using the different methods. All the methods are very important. Why should we conducts are again the Brinell harness test, because yesterday we have been conducted the Rockwell harness test. The aim of that Rockwell harness test is to determine the hardness value of the given sample. Right, today also we are again conducting the hardness test. The name only it is different, is a Brinell hardness test. Why should we conduct again? Because yesterday only we done that. So why we take once again the Brinell hardness test? So suppose if you have these kinds of the questions in your mind, now let me to clear. So I told you that yesterday only, all the three processes are, all the three techniques on all the three experiments are very important, because some particular type of materials, suppose in our hand we have some kinds of the materials, but some kinds of materials are attributes the good results when we are selecting that particular machine only. Some materials are not suitable for the Brinell test. Some materials are not suitable for the Rockwell test. Some materials are not suitable for the weaker conductions. So that's the reason the materials will give their or their attributes their good results when we come across the particular or a suitable experiment for them. Then only we can get the proper and proper results. That's the reason that based on the kinds of the materials, here we are changing our methods. Brinell, Rockwell, and Vickers. I hope you understand why we need to conduct all the three methods. You have to have that practice, or you have to have that knowledge how to conduct all the three experiments, because all the three are very important, because we have to use all the three experiments successively for different kinds of materials. I hope you understand. While once again we are taking the hardness test, but just we are changing the method and machines. Here one more thing I would like to share you. The machine here we are using the same machines what we have been gone through the last class, or what we have gone through the Rockwell test. The Rockwell test and Brinell test, both experiments are done in same machine. Keep it in your mind. Brinell and Rockwell tests are done by a single machine, which means for these two methods which we are using the same machines. For Rockwell and Brinell conduction, which we are using the same machine is able to conduct the both the experiments, but there will be the principle, or yes, there will be the method, there will be the principle of a method to determine the hardness value of the given sample is different. That's it. Somewhere this Brinell test will take the diversity. Hence, this has different principle to determine the hardness value of the given sample when we are comparing to the Rockwell. But the machines and almost 80% of procedure will be the same. Only the determining of the hardness value, the two steps are different. Means the working method of determining the hardness value of the given sample is different. Arrangements, procedures, everything will be the same. In the single machine, we can able to perform the both the experiments. And hope you understand. Yes, yesterday we have been discussed this machine, or yesterday only we have been seen this machine. Yes, here there will be the something will be changed at this side. Here we are not using the automatic loads. This is the manual load. Here we are, as we can see the image at this side, this is the manual hanger with loads. Here we are applying the manual loads, right? But this is the oldest method which we are applying the loads by manually. Nowadays we have automatic machines, as we can able to see the last image here. So better I can take the Rockwell test. So just give me 2 minutes. Yes, so better I can explain through this, right? Yes, Rockwell test. See, Nothing will be changed in the arrangements of machine. See, the same machine which we can use. The machine construction of the machine and the arrangement of the machine for Brinell test is will be a same, and this table is also will be the same. Nothing will be changed, but where exactly this Brinell will take the diversity whenever we are comparing the Rockwell harness, I will clear later. So the first we can able to see this machine will be the same for the Brinell also. Already we have been discussed, this will be the indenter holder. Here we are using the most commonly we are in Brinell we are using the ball indenter only, right? So this is the dial indicator, this is the load unit or load device. With the help of this unit you can able to set your loads, right? So we already perform this, and here the hand lever, so loading for the purpose of loading and unloading. So this is the screen, so this is the hand lever. With the help of the hand lever, once you start rotating clockwise direction, this hand will be the rise up. Everything will be the same, already we have been discussed in the previous class. Now this chart is also same, we know very well about this chart. This chart is a very important. At the time of the examination only we will give you, or only we will provide you the materials. May the given sample may sometimes it is a carburized steel, or may sometimes it is a cementite carbide, or may sometimes it is copper, aluminum, brass, or gray cast iron, right? So yourselves you can identify the what kind of the material. So I have got maybe the examiners or maybe the instructors or any one of the examiner, maybe internal or external examiner will give you the samples, or instructor will suggest or examiner will suggest you to take this copper aluminum. So you need to determine the hardness value of the sample, right? So any one of these you can able to get in the final examination, right? And sometimes the instructors or examiners will not tell you to this is aluminum and this is brass. So they will not tell this. Yourself in that situation, yourselves you can identify whether this is aluminum or copper, because uh, because you have already the practice lab. You have to have that practice in your practice lab. You are coming regularly and you are conducting the you are attending the practice lab, you are practicing the things. Definitely whenever the same materials will come across, definitely you would have observed that, you would have finding that, oh, this is aluminum, already we have been gone through this experiment. Okay, this is aluminum. This is the basic previous knowledge you can apply here. Then you can come to know what kind of material it is. Suppose if you finding this is the aluminum, then for aluminum, so what are the parameters we need to be set? Yes, now you finding this is the aluminum, then for aluminum what are the factors we need to be set? Here the ball indenter we need to take, the scale B scale we need to take, and initial load we need to apply the 10 kg force, and major load we need to apply for the 100 kg force. So based on this material, so you have to select. This chart will affix to the machine. So where I can get this chart? So this chart is itself in the machine. Whenever you come across to the laboratory, watch in offline mode, definitely you can able to see this chart. This chart is affixed to the machine itself in the machine. This chart, just you need to uh, identify the what kind of material I have been taken. Based on that material, you just go towards to the machine. That machine has a chart. Through the chart, you can determine all the values. Aluminum is there in your hand, then you can take the B scale, then you can take the ball indenter diameter dimensions and minor loads and major loads, everything you have to collect it. Then you can start performing the experiment. Hope you understand. The machine will be the same for Brinell test. The machine will be the same, this chart will be the same, everything will be the same, right? The only thing is the calculation or determination of the Brinell number is different, that I will clear at the end. Yes, so now I will back. Okay. Now I will coming to the Brinell test. Yes, so theory already we have been discussed. Yes, now the one more important thing is, sir, how this Brinell test is differ. right? That also I will clear in the theory. Then we will go for the procedure, and again, once again, we will discuss in detail. So yes, let's start to the procedures. We'll tell you through the procedure. Meanwhile, we will discuss through the procedure. We will discuss about the calculation and everything. Now coming to the procedure. Yes, this is the procedure of the Brinell test. So to determine the indentation hardness of given sample, any one of among these four. Mild steel, maybe in the examination you may got mild steel, you may got cast iron or brass or aluminum material. Now we need to determine the hardness value of any one of these samples. Okay, so step one, this is here we have a machine. So this is a machine is a manual machine it is, but everything will be same here. The only thing we need to apply the loads by manually. But why I'm not highlighting this manual operation, because in our laboratory we don't have these arrangements. This is an oldest method. Here we need to change our loads. These are the just these are the load device or load units. We need to apply by manually, replacing and inserting, by replacing and inserting, just like in dumbbell shapes. So these loads we need to arrange by manually. So this arrangement we don't have in our laboratory. We have automatic arrangements in our laboratory. Just here there will be the unit is there. In this unit you need to set the loads, right? So you need to set the loads. Here the hand lever is there. You can, with the help of the hand lever, you can load it and unload it, right? This is the machine. So the first step, once again I will explain you. So many of them are absent yesterday, so let me to explain so one more time, because this is an opportunity, because that Brinell test is also like Rockwell hardness test. So here the procedure is simple. Just now you are collecting the aluminum material, then you can once you got the S, this is the aluminum material, then you can collect all the parameters or note on all the parameters. Okay, scale, load, diameter of the indentation, minor load, major load, everything you need to collect it. Thereafter, now you need to perform and take the samples and keep it in the anvil, right? Here that is the first step. And second step, you have to select the indenter, then you can set the indenter in the indenter folder, right? This is the first step. Select the workpiece and keep it in upon the anvil. Then you can select the indenter, different types of the different shapes and size of the indenter available. Here obviously in a Brinell test we need to take the ball indenter. Then the described dimensions with respect to the material that is mentioned in the chart. As per the chart, you can select the dimension of the or diameter of the indenter, then you can fix into the indenter folder. Then start rotating this anvil. So in the clockwise direction, this hand lever, with the help of the hand lever, can rotate the clockwise direction. Definitely the screw will be the rise up. The anvil is obviously the anvil is rise up till this here we need to keep the workpiece this till this rotation is still that workpiece is just attached to the ball indenter point. Whenever we make ensure this contact between the ball indenter as well as the workpiece, you need to stop it, right? So once you stop this process, and you can go for the dial indicator notation, small red dot, right? I hope you understand that. Yes, so better you can take Rockwell test only, so that you can understand, because I think once again we will go for the Rockwell. Yes, so this is over. Now coming to the second step. So here we need to select, this is the first step. Now we are selecting the materials, whether it is a cast iron, mild steel, or spring steel, or else brass or aluminum, anyone you can select. Then here we need to rotate the anvil. So once we rotate this anvil, rotate this anvil, this screw is rise up, and now the anvil will rise. Now there will be the contact between the workpiece and the ball indenter, right? This is about the minor load. Once this minor load, sorry, once this workpiece is just touches to the ball indenter, here we need to uh, focus on the small dial. So here we have a here we have at the top of the machine, here we have a dial. Now this dial I am magnifying here for the understanding purpose. This dial only, here we are magnifying it. So this is a big dial. So inside there will be the one more small dial. The procedure will be the same now. So here we need to make ensure the small pointer, as we can see here, the small pointer, here we have a small pointer. This small pointer is just touches to the red dot. Till that we need to rotate this anyway, because this small pointer is initially it is somewhere, it is not at the inline of the red dot. It is somewhere, it is in the dial indicator, right? Maybe whether it is in here or here or here, somewhere it is in the dial indicator, small dial indicator. Whenever you start rotating, whenever you are establishing the close contact between the workpiece and pointer, now this pointer now whenever we are making ensuring this close contact, now this pointer is fluctuating somewhere here, fluctuating, and it is moved towards to the red point. Suppose initially it was there in that here. Whenever we are rotating this will be slightly moves down and touches to the red dot. Till that we need to rotate this annually. When this small pointer from here to here, now it will be touches the red dot. Now we can stop rotating of anvil. Hence this means the minor load of 10 kg force is applied, which means there is a close contact between, that is the firm contact between the, that already we have been discussed, that we have been practicing that one self evaluation, that firm contact between the workpiece and the surface of the indenter, that we can able to understand when this small pointer is just touches to the red dot. Now this is the second step. Next, third step is that, yes, now we are, however we are applying this minor load, right? Then we need to apply the major load. So here we have, here this is the, you can able to understand better the way we are this same machines which we have in our laboratory. The instead of applying the manually, now we need to apply the automatically. So this is the device or unit, this is the loading unit. Here we need to set the, this is the screw is there, with the help of the screw we need to set the prescribed load, which is from the scale, that is depending upon the workpiece. Now here we have different loads. This is the load setter. The 150 is there. If 150 is suitable for your particular material, then you can take the 150. If it is 200 is suitable for, you can take 200 or 250 or 300. So that is depending upon what kind of the material you are using. Then you need to set this load. Once you set the load, here there will be the hand lever is there. With the help of the hand lever, now you can load it. This is once you can pull back, that is a load in condition. The full forward, that is unload condition. So now we need to, once we make ensure the particular load, then we can pull back to this lever. Now it is in load condition. This is the step 3 is over. So now the why I am again I'm repeating the step 3, because still we need to, once we unload it, we don't take the values, wait for 30 seconds or 20 seconds. After loading, again we need to wait for 10 to 15 seconds. This is the study time, what we can able to see. This is the study time. We need to wait for 10 to 15 seconds. After the 10 to 15 seconds, when that study time is over, then with the help of this hand lever, now you can pull forward. Now you can make ensure this, the load will be in unload condition. When we are putting this in unload condition, the pointer, big pointer in the big dial indicator, this will start rotating again, or it will be moving, or it will show some values. When you are unloading, when you are keeping this in unload, at that time this pointer will be show some particular values. So for example, here 94 is showing. When you are putting in unload condition, this big pointer will be showing some values. something this shows here in between the 95 and 94. So hence we can take it is around about nearly equal to 94. This is the value. While putting in a load condition, also this pointer will be rotating, and thereafter after the study time that will show some values. Don't No need to take that values whenever it is in load condition. Don't take the values from the dial indicator. When you are putting to the unload condition, again this pointer will be a moves, and that will show some values. That value only you need to take. That will be the hardness value of the given sample. This is for Brinell only, right? This is for Brinell only. If it is a sorry, this is for this is for Rockwell only. The Rockwell, there is no calculation, there is no formula. Directly what that big point is shows in from the dial indicator. Directly you can take that the pointer shows values. You can write it here. This will be experiment will be the end. In case of Brinell, sorry, in case of Rockwell. If Brinell, no need to, after unloading also, no need to take the values from the dial indicator. If you take the values from the dial indicator after unloading, that will be the Rockwell test. In case of Brinell test, no need to take, even after putting in unload condition, no need to take the values from the dial indicator, because this Brinell test has some formula. So we need to uh, apply the values in the formulae, so that I will show you. So once we simplify the formula, then only we will get the Brinell number of the given sample. See, now I will come to here. Yes, once you perform the as per the procedures I have explained already. So as per the Rockwell test, how we are gone through the Rockwell test, the same way we can gone through. When you unload it after loading, that will be the show some values. If you take that values, that will be the Rockwell harness test. You don't take that values, just you can observe it and collect the samples. In Rockwell harness, there is no need to collect the samples and nothing else. Just you collect the samples and look into the surface of the sample. That sample has some indentation or penetration, right? So here, so this is the, just like this specimen, over this specimen there will be the small indentation or penetration. You just focus that indentation or penetration, because we need to simplify the formula here. That's what we need to determine the indentation of the diameter of the indentation. Because we are applying the force, definitely there will be the penetration over the sample. Here we need to note down the penetration of the sample, or to determine the diameter of the penetration. But diameter of the indenter or penetrator already you know, that is from the chart. Maybe it is around about 2 mm or 1.58 mm, right? But now we need to determine we need to fulfill this formula. Then we can simplify this, then only we can get the values that we can say it is a Brinell value. See, so Brinell BHN number is equal to 2p. So 2 into p means applied force. Applied force may sometimes it is 100 150 or 200. So now we will know the p values. P value is as per the type of the material. Now we are we have been selecting through the chart. Yes, 2 into p, around about it is 100 100 and 250 250 or 200 200. We can take the p values. Then 5 into, you know the value of the 5. Then capital D. What you mean by capital D? Anybody? Hmm? See, the capital D, yes, diameter of the ball means diameter of the indenter or diameter of the penetrator. That also already we have been selected depending upon the materials from the chart. That also you note down it. Already you have been noticed that. So that capital D means diameter of the ball or diameter of the indenter or penetrator. Now the 5 into capital D into the bracket, again capital D minus in the root of, so capital D square minus small d square. Here the P is a noun value, that phi is also a noun value, and capital D is also a noun value. So now the small d is a unknown value. And then tell me now what it indicates. Small d is indicates what? Hello? What is the
Diameter of
small
the
d?
indentation.
Yes, 100% correct. That small d is indicates that diameter of the indentation, because we have been applied the 100 kg force or 150 or 200 kg force over the sample by using the indenter. Definitely this indenter or this penetrator will penetrate the sample. Definitely that the shape and size of the ball will be printed over the workpiece, right? We need to determine the diameter of the penetrator, because we have to have this formula. We have to complete this formula, or we have to complete this simplification. This simplification needs some values. The P is already known, maybe it is 100 and 250 or 200, or 5 value also known, the noun and capital T also we know. Now we need to determine the this one. Small d is the diameter of the indentation. If you got this diameter of the indentation, now it's complete. Simplify this, we will get some values. That values we can call it is a Brinell hardness number. Simple case, right? So now I will directly take you into the simulation, or once again the Brinell procedures. Directly we can go for the simulation, no doubt. Right now, Brinell test. Yes, simulation. Directly I will show you the simulation how it's work. See, this is the Brinell machine, but it is a manually operated Brinell machine. Here the load will be the manually operated. You don't get confused. Instead of this manually, now here we have a automatic machine in it or load in it. We can able to apply the load by automatically. The hand lever is instead of here we have a hand lever in our laboratory. Let's start the experiment how it works. Simulation, I will show you the simulation. Yes, you can select the step. The first step is to select the any one of the material. For example, it is a cast iron is there, my steel is there, brass is there, aluminum is there. So as per the instructors, as per the examiner instructions, you can able to take the any one of the material here. Yes, now we are selecting the what we can aluminum, the mild steel we can able to select. Yes, now we are selecting the mild steel. Once you select the mild steel, everything will be open here. So the mild steel, once you select the mild steel, load how much it is, 3000 kg force or 3000 kg is there. So now in terms of 150 kg force we can take into the our laboratory. So assume it is a 3 kg force. So this will be the changes by changing the machines. Now that everything will be the shown here, the load will be shown here. The cast iron is round about, this is the P, this is the T, 10 and 5. This is the steady time, P by, so d square. How we can, how we will get the steady time. So already we have been discussed the, what do you mean, we have been discussed the steady time. Steady time means that pointer will be, that big pointer will be momenting or rotating over the big dial. So that after rotation, that will take some particular point. Don't hurriedly, in hurriedly you don't take the readings, because we will provide the sufficient time to so rotate or move over the dial. After 10 minutes and 20 minutes, that big pointer will be steady at particular number. That number we will take after the 30 minutes, 10 minutes and 5 minutes. That is depending upon the material. If you are selecting the cast iron and mild steel, you need to wait for 30 seconds. 30 seconds will be the steady time. If you are selecting the brass and copper, the 10 seconds will be the steady time. And aluminum, magnesium, if you are selecting 5 seconds will be the study time. So here, so simultaneously here we are the different loads also which we can able to choose for the different materials, 3000, 1000, 10,000 and 500 kg. This is uh, um, sorry, 1000 kg, 3000, 1500 kg, depending upon the material which we can take here the loads also, as well as study time also, right? Now we will move on to the next. Yes, step 2. Step 2, what it seems, now we need to rotate this screw. Why? Because we make ensure that the workpiece and indenter should be in close in contact, right? That's what I am protecting this. Yes, so this will be the negative. Now there will be the gap between the workpiece and the indenter. Now we need to raise the, yes, now I am raising this screw. Now the workpiece of the workpiece, surface of the workpiece and surface of the indenter are in close in contact. They are, the specimen is in position. That's we can call it a specimen in position. Means we make ensure that these should be in close contact, because whatever the load we are applying here, that will be transferred to the workpiece. Hence we can get the proper indentation over the sample. Later we can examine that indenter with the help of microscope, because that indent, that penetration will be very small, that indentation will be very small over the workpiece. We cannot able to predict, or we cannot able to predict the exact size of the exact diameter of the indentation. That's why we need to take the electronic microscope here. Whenever we, so whenever we are placing this workpiece, we need to collect this workpiece and we can place into the electronic microscope. That electronic microscope is focus the workpiece, and then that capture this signal or image in the form of the signals. Then that will be send the signals into the monitor, so in the screen or monitor. That monitor we can able to identify, or we can able to determine the diameter of the indentation, that is equal to small d. Now we will move on to the next step. Yes, now we need to set the load, or we need to switch on the motor. So whenever we switch on the motor, see here, now I am switch on the motor, what happens? Yes, now I am switch on the motor. Now we are already applying the manually the different loads as per the different types of the materials. Now we are applying manually by the loads. Instead of manually, we can able to set the loads here. Here only we are providing the loads. We can able to select the loads, whether it is 100 or 200 or 250. Then we need to load it. Once you set the load, then you need to load it. Now I am so loading this. Yes, this is what study time. The study time, when we are putting that lever in load condition, now we need to wait for the 30 seconds. We need to wait for, because we are selecting the mild steel material. That's what we need to wait for the 30 seconds. Once the 30 seconds is reached, now again you can unload it, right? I hope you understand this. Now we are unloading. After unloading, what happens we will see in the coming step. Yes, now we are unloading. Don't take the values in Rockwell test. Once we unload it, immediately that pointer will show some values. Now directly we can collect that what the indicator shows, that value we can write it in our book, and experiment is finished. But in case of Brinell, not like that. Now we need to collect the workpiece. Once we unload it, then don't take that values of the dial indicator, whatever it may be. You don't take that. Now you need to collect the workpiece, because we need to fulfill our formula. We need to simplify that. After the simplify only we will get the Brinell harness number, so that now we can collect the workpiece. So let them to microscopic view. When we are passing in or when we are allowing that workpiece into the electronic microscope, now just now say here we are getting the diameter of the indentation. How much it is? 4.52. When I am pressing the
4.52.
button, yes, when I am pressing the button, now this microscope is measure the diameter of the indentation that is printed over our workpiece. Now we got the diameter of the indentation, that will be the 4.52. Almost 90% of our work is done now. Only we need to simplify the formula, we will get the results. Hope you understand. And this microscope sometimes itself in the machine at the head of the machine, sometimes we need to take separately. In our laboratory we have a separately microscope. At that condition you can select this. Once we are unloading, we need to collect the samples. You can go separately. Separate arrangement is there for the microscope. You can keep the workpiece properly in the microscope. You can examine the microscope like this. With the help of the microscope, you can examine the diameter of the workpiece. Now the diameter of the workpiece is 4.52. I hope you understand this process. Now we will move on to the next. Yes. Here there will be the observation or chart. So material, so you know very well, we are selecting at the beginning, we are selecting the steel material. The diameter of the indenter is 10 mm. Load we are selecting the 3000 kg, and p by 2. Also we are waiting for the study time is 30, right? 30 seconds it is. Then the diameter of the indentation. So see, diameter of the indentation is 4.52. Right, so the average we are taken to the 4.52. This is the small d, this is the capital D. Hope you understand. Is small d, this is capital D, this is a P. Now the average diameter, because of the two trials, we will get the same diameter. Then the average diameter of the indentation is 4.52. Now the small d by capital D is 0.452. Right, now this is the Brinell number. How we will get this Brinell number? Here we have a formula. So 2 into p. P means 3000 kg pores. Now 5, we know the Pythagoras value. The pi value we know, everybody knows the pi value. And capital D. So capital D is 10 mm, and into the bracket again capital D 10 mm minus into the root of capital D square, and means 10 square, minus small d. The small d is 4.52. That 4.552 square. Then you can simplify this. You will get the 176.96. This will be the hardness number of given sample by Brinell test, or Brinell hardness number of given sample. Right, this is the second trial. Once again I will try to show you. Already time is over. Okay, let it be. So once again you can observe this, how this I'm audible? Hello?
Yes, sir. Yes, sir.
Yes, once again I will show you the second trial, how the machine works through the simulation. See, once you need to rotate this hand wheel, the hand lever, because we need to make ensure that this hand wheel will be a close contact with the workpiece. Yes, now you can move this, right? Okay, now we are making sure this workpiece as well as the indenter is close in contact. Now we need to set the major load. That will be the minor load. Now we need to set the major load. Yes, now I will set the major load. Yes, major load is applied on about 3000 kg. Now we need to put the load conditions. Now it is loading condition. At this time we have to wait for the 30 seconds. Yes. Now this is 30 seconds. This is, we can call it as a steady time. Now we need to unload it. Now this is unload. This is enough for the Rockwell test, but in Brinell we need to move on. Yes, now we will get the impression over the workpiece. Then we can collect the workpiece, keep it into the microscopic examinations. Now we need to determine the diameter. Just again, yes. Now we got that. Second time we will get 4.67 diameter of the indentation. That's enough. Now again we will get the values. Now the first trial we have been scored 176 Brinell hardness number. The second time now we got 165 Brinell hardness number. Average of these two values, now we will get the 171 is the average value of Brinell number of given sample. Hope you understand.
Yes, sir.
Yes, is it clear or not? Is clear? Is clear or not?
Yes, sir. Clear.
Yes. Okay. So thank you. Now the time is up because we have a meeting. Now I will wind up my class. Tomorrow we will discuss the one more experiment. Right? Maybe it is a Vickers harness test. We will discuss. Now I will just wait for 2 minutes. I will take the attendance. Yes. Right. Now you can leave your meeting. So
Thank you.
we will meet. Okay, we will meet tomorrow. Not tomorrow. Monday we will meet at afternoon.